Assalamu alaikum students. I am Wasim Ikram. This is the 17th lecture in a series of 45 lectures on digital logic design. लास्ट लेक्चर में हमने दो नए कॉम्बिनेशनल फंक्शनल यूनिट्स पे बात की थी। पहला जो था कंपैरेटर सर्किट था, जो हम पहले भी डिस्कस कर चुके थे। दो वर्जन्स थे कंपैरेटर सर्किट के। एक जो है पैरेलल कंपैरेटर सर्किट, जहाँ पे सारी बिट्स को चेक किया जाता है एंड देन ऑन द बेसिस ऑफ दोस बिट्स वी गेट 3 डिफरेंट आउटपुट्स। दूसरा हमने वर्जन जो डिस्कस किया था द आइटरेटिव बेस्ड सर्किट। आइटरेटिव बेस्ड सर्किट में हमने ये बताया था कि एक मॉड्यूल होगा जिसके आप मल्टीपल कॉपीज बना सकते हैं और आपस में जोड़ सकते हैं। उसमें फ़ायदा उसका ये था कि अगर आपने लेट्स से 16 बिट का कंपैरेटर यूनिट बनाना है तो आपको एक्सटर्नल लॉजिक यूज़ नहीं करनी पड़ेगी, जो कि आपको पैरेलल कंपैरेटर में यूज़ करनी पड़ती है। दो सर्किट्स हमने डिस्कस किए थे। एक जो था A=B, उसका आइटरेटिव सर्किट बनाया था। और दूसरा जो कंपैरेटर सर्किट हमने देखा था A>B, उसका एक आइटरेटिव सर्किट बनाया था। उसकी एग्जांपल्स भी देखी थी, दो मॉड्यूल्स को आपस में कनेक्ट करके A=B भी इम्प्लीमेंट किया था, A>B भी इम्प्लीमेंट किया था। एंड वी सेड वी कुड इम्प्लीमेंट अ सिमिलर मॉड्यूल यूजिंग सेम सेट ऑफ गेट्स फॉर A<B। दूसरी जो चीज़ हमने देखी थी, जो कमर्शियली अवेलेबल 4 बिट कंपैरेटर है, बेसिकली वो आइटरेटिव बेस्ड कंपैरेटर है। उसका हमने कनेक्शन देखा था। यू कैन इम्प्लीमेंट 12 बिट कंपैरेटर बाय कनेक्टिंग 3 ऑफ दोस 4 बिट चिप्स। नेक्स्ट जो हमने फंक्शनल डिवाइस देखी थी, जिस पर डिस्कशन की थी, डिकोडर था। डिकोडर बेसिकली हमने कहा था दो इंपॉर्टेंट उसके फंक्शंस हैं किसी भी कंप्यूटर सिस्टम में या डिजिटल सिस्टम में। एक तो ये है कि उससे हम डिफरेंट डिवाइसेस को सिलेक्ट कर सकते हैं। सो यू हैव अ डिकोडर, इट हैज़ मल्टीपल इनपुट्स एंड मल्टीपल सेट ऑफ आउटपुट्स। By applying a certain code at the input of the decoder, one output or multiple outputs can be selected which represent the input code. So अभी तक जो हमने डिस्कस किया था बाइनरी, सिंपल बाइनरी डिकोडर की बात की थी। यू कुड हैव 2 to 4 बाइनरी डिकोडर, जिसमें 2 इनपुट कोड्स आप अप्लाई करेंगे, 2 बिट इनपुट कोड अप्लाई करेंगे। उसकी वजह से 4 में से एक आउटपुट सिलेक्ट होगा, सो दैट सिंगल आउटपुट कैन बी यूज टू सिलेक्ट एनी डिवाइस। दूसरा जो हमने एप्लीकेशन थी डिकोडर की, वो था इंस्ट्रक्शन डिकोडिंग में। कंप्यूटर में एज यू नो ऑल प्रोग्राम्स विच यू राइट आर कन्वर्टेड इनटू मशीन कोड। बाइनरी की टर्म्स में 1s and 0s के टर्म में रिप्रेजेंट होते हैं। सो व्हेन यू एग्जीक्यूट दीज प्रोग्राम्स, वन इंस्ट्रक्शन इज फेच्ड, it is decoded basically, as we said in the last example, add है 1010, let's say 1010 represents the add function। तो कंप्यूटर कैसे उसको यूज करेगा, एक डिकोडर के इनपुट पे ये अप्लाई करेगा। डिकोडर का जो आउटपुट होगा वो ऐड सर्किट को एक्टिवेट कर देगा, सो एडिशन हो जाएगा। इसी तरह आप सब्ट्रैक्शन कर सकते हैं, कोई और भी ऑपरेशन कर सकते हैं। डिकोडर सर्किट की हमने इम्प्लीमेंटेशन देखी थी, 2 to 4 डिकोडर सर्किट की, उसका फंक्शन टेबल देखा था। हमने बात की थी कि डिकोडर जो हैं डिफरेंट टाइप्स के अवेलेबल हैं। 2 to 4 है, 3 to 8 है। इनको डिफरेंट कॉम्बिनेशंस में आप कनेक्ट कर सकते हैं टू फॉर्म लार्जर डिकोडर्स। तो आज हम अपनी डिस्कशन कंटिन्यू करते हैं, डिफरेंट डिकोडर्स देखते हैं, उनके आपस में कनेक्शंस देखते हैं, इम्प्लीमेंटेशंस देखते हैं। उसके बाद एक और चीज़ है, इसका जो ऑपोजिट है, इनकोडर्स। इनकोडर्स के बारे में बात करेंगे, इनकोडर्स क्या होते हैं। So let us start our discussion by looking at the 3 to 8 decoder. We'll start today's discussion by looking at the 3 to 8 decoder. 3 to 8 decoder, as the name indicates, has 3 inputs and 8 outputs. इसका हम फंक्शन टेबल भी देखेंगे, एग्जैक्टली करता तो क्या है वो हमें पता है। बेसिकली 3 बिट इनपुट कोड आप अप्लाई करेंगे, आउटपुट में जो 8 आउटपुट्स हैं उनमें से एक सिलेक्ट हो जाएगा, एक्टिवेट हो जाएगा उसमें। दिस 3 to 8 decoder has 3 chip enable इनपुट पेन्स। पहले जो हमने 2 to 4 डिकोडर देखा था, उसका चिप इनेबल पेन एक ही थी। नाउ दिस हैज 3 चिप इनेबल इनपुट्स। दिस अलाउज डिफरेंट 3 to 8 डिकोडर्स, मल्टीपल 3 to 8 डिकोडर्स टू बी कनेक्टेड टुगेदर टू फॉर्म लार्जर डिकोडर्स। फॉर एग्जांपल, आप दो जो हैं 3 to 8 डिकोडर्स आपस में कनेक्ट कर सकते हैं टू फॉर्म 4 to 16 डिकोडर्स। दैट मीन्स इट हैज 4 इनपुट्स एंड 16 आउटपुट्स। सो बाय अप्लाइंग a 4 bit code at the input, you can select one out of the 16 outputs. Let's have a look at the function table which describes the operation of the 3 to 8 decoder, and then we will have a look at the circuit diagram where we connect the two 3 to 8 decoders to form a 4 to 16 decoder. Let us first look at the function table of the 74LS138, the 3 to 8 decoder. As seen in the function table, there are 6 inputs: G1 input, G2A bar input, G2B bar input. These 3 inputs are the chip enable inputs. G1 is active high, G2A and G2B are active low. C, B, A are the data inputs or the code inputs, which allows us to select one out of the 8 outputs. There are 8 outputs: Y0, Y1, Y2, Y3 up to Y7. All are active low. Now, to operate the 3 to 8 decoder, all the chip select pins should be activated. So G1 should be set to 1 because it is active high, G2A should be set to 0 because it is active low, and G2B should also be set to low because it is active low input pin. Any other combination would not enable the chip, as can be seen by the first 3 rows in the function table. Now, by enabling the chip, you can apply 3-bit code at the inputs A, B and C. So, by having 0, 0, 0 at the inputs A, B, C, Y0 output is selected. Since it is active low, therefore you see a 0. All the remaining outputs are 1. Similarly, by having the input code 0, 0, 1, Y1 output is selected. By selecting the input code 101, Y2 output is selected, and so on. Finally, if you have the code 111, Y7 output is selected, it has a 0, remaining outputs are 1s. Let us now look at the implementation of a 4 to 16 decoder using 2 3 to 8 decoder chips. Now, the inputs A, B and C of both the 3 to 8 decoders are connected together. Looking at the chip enable pins, the 3 chip enable pins, the G1 enable pin for the first decoder is connected to 5 volts, so it is enabled. G2A and G2B, the active low enable pins, are connected to the D input and an enable input. Looking at the second 3 to 8 decoder, G1 enable pin is connected to the D input. G2A and G2B, the 2 active low pins, are connected to the enable input and ground respectively. Now, let's look at the function of the 4 to 16 decoder. Let us suppose you apply a 4-bit code 0, 0, 0, 0. All 4 bits are zeros. Now, the 0 at the D input would activate the first 3 to 8 decoder, the decoder shown on the top, whereas the lower 3 to 8 decoder would be inactivated because you have a 0 at the G1 enable input. Which output would be selected? Basically, it depends on the input code at inputs A, B and C. Since it's 0, 0, 0, therefore Y0 output would be selected. It would be 0 as it is active low. Outputs Y1 to Y7 would be set to 1. Similarly, outputs Y0 to Y7 of the second 3 to 8 decoder would all be set to 1 because that particular chip has not been selected. Let us suppose you apply the code 1, 1, 1, 1. All 4 bits are set to 1. Now, looking at the D input, it is 1. So, the top 3 to 8 decoder, it is not selected because G2A has to be active low. Looking at the bottom 3 to 8 decoder, G1 is connected to D. Since D is 1, therefore G1 is activated. G2A is connected to the enable pin. It is set to 0, so it is active again. And G2B is permanently connected to ground. Therefore, the second 3 to 8 decoder chip has been selected, whereas the first 3 to 8 chip has been deselected. Now, what is the output state of this 3 to 8 decoder? Since A, B and C are all 1s, therefore Y7 output is activated. Y7 output of the second 3 to 8 decoder. It would be set to 0. Y0 to Y6 outputs would be set to 1. Similarly, the Y0 to Y7 outputs of the first decoder would all be set to 1, indicating that it is inactive. We have looked at the function diagram of a 3 to 8 decoder. It has 3 inputs and 3 chip select inputs, and of course 8 outputs. We have also seen the implementation of a 4 to 16 decoder using the 2 3 to 8 decoder chips. Now, one interesting thing which can be done by using these decoders, 2 to 4 or 3 to 8 decoders, is to implement a function generator. Well, how do we implement a function generator? Let's suppose you have a 3-variable function table. So, 3-variable function table would have input variables A, B and C. You have 8 possible input combinations. The output would be, of course, a single column representing F, the output. Let's suppose the first term, min term 0, 0, 0 is set to 1, and the last min term 1, 1, 1 is again set to 1. So, how would you implement this function? Well, you can use logic gates. Now, this same function can be implemented using a decoder. Let's consider the 3 to 8 decoder. The inputs are connected to the 3 variables A, B and C. Now, let's suppose you apply the code 0, 0, 0. What happens? The output Y0 is going to be activated. It would be set to 0, whereas other outputs would be set to 1. Similarly, if you apply the combination 1, 1, 1 at the input of the 3 to 8 decoder, what happens? The output Y7 is going to be selected. It is going to be set to 0, whereas the remaining outputs would be set to 1. Okay, since we are interested in implementing the function table which has only 2 min terms for 0, 0, 0 and 1, 1, 1, what do? Basically, you connect a NAND gate at the output of the 3 to 8 decoder. Why a NAND gate? Basically, if you remember, the 3 to 8 decoder has active low outputs. Okay, so if you are going to be implementing a function in terms of sum of products, right? So 000 represents a product term, 111 represents another product term. Now both these product terms have to be odd together. Now how would you set the active low outputs to active high? You would add two inverters, or you would connect two inverters at Y0 output and Y7 output, and then you would connect a 2 input OR gate. What is the end result? What do you get at the output of the OR gate? Basically, it would be a 1 when you apply the code 000 or the code 111. For all other codes, the output would be a 0. So basically, you have implemented a simple function generator based on SOP, the sum of product terms. Similarly, you can implement a function generator based on product of sum terms. If you just consider that same function table where the term 000 gives an output of 1 and the term 111 gives you an output of 1. How many max terms are there in this function table? Basically 6 max terms starting from 2, 3, 4, 5 and 6. Now if you look at the 3 to 8 decoder, if you apply any of these 6 terms, 2, 3, 4, 5 and 6, the output would be 0 at the respective output pins. Now if you connect an AND gate, okay, AND gate is basically performing the product of sum terms. The output would be a 0. Let us have a look at the implementation of a function generator using these 3 to 8 decoders. Consider the 3 variable Karnaugh map having the max terms 0, 1, 3, 5 and 7. How is the Boolean expression going to be implemented using 3 to 8 decoder? The 3 variables A, B, C are directly connected to the inputs A, B, C of the 3 to 8 decoder. The G1 chip select pin is permanently connected to 5 volts, logic 1. G2A and G2B, the active low chip enable pins, are grounded. So the chip has been enabled. Now, when the code 000 is applied, Y0 is going to be selected. It would be set to 0. When the code 001, max term 1 is selected, Y1 output would be activated. Similarly, when the max term 3, 011 is applied at the inputs ABC, Y3 output would be activated. And similarly for the max terms 5 and 7. Now, by connecting a 5 input AND gate to the inputs Y0, Y1, Y3, Y5 and Y7, we have implemented a POS based Boolean expression, product of some form of the Boolean expression. The function table can be implemented in the form of SOP, an SOP Boolean expression by using the same 3 to 8 decoder. The input variables ABC are directly connected to the 3 inputs ABC of the decoder. The chip selects are set to or connected to 5 volts, 0 volts and 0 volt. The min terms defined by the function table are 2, 4 and 6. Therefore, when 010 code is applied at ABC for min term 2, Y2 output is going to be selected. Similarly, when 4 is applied at the input of the 3 to 8 decoder, Y4 output would be selected, and when a 6 is applied at the input of the 3 to 8 decoder, Y6 output would be selected. Now, all 3 outputs are connected to the input of a NAND gate. Basically, NAND gate, if you have a look at the alternate symbol for a NAND gate, it is an OR gate with 3 bubbles at the input, meaning 3 inverters. The 3 to 8 decoder has an active low output. So by connecting 3 inverters at the input of the OR gate, the 3 active low outputs are being converted to active high. So basically, by connecting an AND gate, sum of product implementation of the function has been carried out. We have just looked at the implementation, or rather the use of 3 to 8 decoder to implement Boolean expressions, both in the sum of product form and the product of sum form. Up till now, the decoders which we have looked at, the 2 to 4 and 3 to 8, only activate a single output. For the 2 to 4 decoder, when you apply a 2-bit code, only 1 out of the 4 output is selected. Similarly, for a 3 to 8 decoder, when you apply a 3-bit input code, only 1 out of the 8 outputs is selected. Now, we had studied the BCD to 7 segment decoder. BCD to 7 segment decoder, basically it has 4 inputs representing the 10 BCD numbers, and for each combination of BCD numbers, multiple output segments are activated. For example, you need to display the number 0. So, जो BCD कोड होगा जो आप अप्लाई करेंगे वो होगा 0000. कौन से सेगमेंट्स एक्टिवेट होंगे? सारे सेगमेंट्स एक्टिवेट होंगे एक्सेप्ट फॉर द सेगमेंट G. इसी तरह अगर आपने 7 डिस्प्ले करना है, सो यू वुड अप्लाई एन इनपुट ऑफ 0111 रिप्रेजेंटिंग BCD 7. आउटपुट पे क्या होगा? सेगमेंट A, सेगमेंट B एंड सेगमेंट C वुड बी एक्टिवेटेड. बाकी जो सेगमेंट्स हैं दे वुड रिमेन इनएक्टिव. सो पहले केस में आपके 6 सेगमेंट्स एक्टिवेट हुए, दूसरे केस में 3 सेगमेंट्स एक्टिवेट हुए. सो मल्टीपल आउटपुट्स आर बीइंग एक्टिवेटेड. Now, if you remember, BCD to 7 segment decoder का हमने function table देखा था. Function table में we had 16 possible combinations because we had 4 variables representing the 4-bit BCD and we had 7 outputs, one for each segment. So A, B, C, D, E, F and G, 7 different outputs. हमने Boolean expressions भी derive की थी हर segment के लिए. वो example में हमने देखा भी था for segment A and B and G. Now we can directly implement circuits which generate or which activate the output of segment A to 1 or set it to 1 when the number 000 is applied, for example, or the number 7 is applied. So similarly, segment B के लिए हम एक circuit बना सकते हैं. जब भी appropriate numbers आप apply करते हैं input पे, segment B should be set to 1 and similarly for all other segments. एक तो तरीका वही है कि आप लॉजिक गेट चूज करें, उसे इंप्लीमेंट कर रहे हैं. दूसरा जो आसान तरीका है टू इम्प्लीमेंट दिस BCD to 7 segment डिकोडर वुड बी टू जस्ट बाय ए चिप जो कमर्शियली अवेलेबल है. सो जो 4-bit जो है BCD to 7 segment डिकोडर चिप है, इट इज द 7447. ऑफ कोर्स इट हैज 4 इनपुट्स एंड 7 आउटपुट्स. The 7447 BCD to 7 segment decoder chip, in addition to the 4-bit input and 7-bit output, has certain other inputs and outputs. Now these extra inputs and outputs allows the BCD to 7 segment decoder to control the display digits. Basically, if you display a fraction such as 23.71, let's suppose you have 3 digits which represent the integer part and 3 digits to represent the fraction part. So 23.71 जब आप डिस्प्ले करेंगे, मोस्ट सिग्निफिकेंट डिजिट पे क्या होना चाहिए? बेसिकली कुछ भी नहीं होना चाहिए, वो ब्लैंक होना चाहिए. इसी तरह जो 71 के बाद जो है लीस्ट सिग्निफिकेंट डिजिट, वो भी ब्लैंक होना चाहिए. सो ये जो 3 एक्स्ट्रा इनपुट्स हैं BCD to 7 segment डिस्प्ले के साथ, डिकोडर के साथ, बेसिकली ये जो ट्रेलिंग जीरोज हैं उनको कंट्रोल कर रहे हैं. अगर किसी नंबर में ट्रेलिंग जीरो है तो उसको डिस्प्ले नहीं करेगा. इसी तरह किसी नंबर के शुरू में जीरोज आ रहे हैं तो उसको भी नहीं दिखाएगा उसमें. We are not going to look at the actual implementation of the circuit inside the BCD to 7 segment decoder, but just to recap, हमने जो पहले equations या Boolean expressions जो derive की थी segment A, B and G के लिए, उसको जरा दोबारा से देख लेते हैं. उनकी जो implementation है using simple logic gates, उनको भी जरा देख लेते हैं इसमें. The Boolean expression representing segment A is A plus C plus BD plus B bar D bar. The circuit implemented using this expression has a single OR gate, 2 AND gates and 2 inverters. The Boolean expression representing segment B is B bar plus C bar D bar plus C D. The implementation of this expression is through a single OR gate, 2 AND gates and 3 inverters. Similarly, the implementation of segment G is A plus B C bar plus C D bar plus B bar C. It uses a single OR gate, 3 AND gates and 3 inverters. Similarly, you can have expressions for other segments and each segment can be implemented using OR gates, AND gates and inverters. Now, most of these segments have combinations which are used by other segments. So, you can save on these similar terms by having just a single circuit. The 7447 BCD 7 segment decoder circuit economizes on these gates by having a single gate for single terms. We have discussed 2 different decoders, the binary decoder which has either 2 inputs or 3 inputs and multiple outputs, only one output is activated. We have also discussed the BCD to 7 segment decoder which again has 4 inputs and 7 outputs. More than one output is activated on the application of a BCD code. We have a third type of a decoder, the BCD to decimal decoder. The BCD to decimal decoder is similar to a 4 to 16 decoder. 4 to 16 decoder, basically you apply a 4-bit code and one out of the 16 outputs would be selected. BCD to decimal decoder has only 10 outputs and each output represents the decimal digits 0 to 9. So if you apply, let's say, a BCD number such as 11 which is invalid, no output would be selected. Similarly, 12, 13, 14, 15. अगर ये इनपुट्स आप अप्लाई कर रहे हैं BCD टू डेसिमल डिकोडर के इनपुट पे, अगेन आउटपुट जो है चेंज नहीं होगा, कोई भी एक्टिवेट नहीं होगा. सो बेसिकली 4 इनपुट्स एंड 10 आउटपुट्स. सो अगेन BCD टू डेसिमल डिकोडर के डिफरेंट एप्लीकेशंस हैं. लेट अस डिस्कस एनकोडर्स. व्हाट आर एनकोडर्स? बेसिकली एन एनकोडर फॉर्म्स अ फंक्शन व्हिच इज द एग्जैक्ट ऑपोजिट ऑफ ए डिकोडर. एनकोडर के भी मल्टीपल इनपुट्स हैं और मल्टीपल आउटपुट्स हैं. नाउ बाय सिलेक्टिंग एनी वन इनपुट यू गेट ए कोड व्हिच रिप्रेजेंट्स दैट इनपुट. So for example, if you have a 4 to 2 encoder, उसके 4 इनपुट्स होंगे, 2 आउटपुट्स होंगे. अब आप चौथा इनपुट जो है वो सिलेक्ट कर देते हैं बाय सेटिंग इट टू लेट्स से लॉजिक 1. आउटपुट पे क्या आएगा? आपके पास 2 बिट कोड आएगा 1 1 रिप्रेजेंटिंग दैट द फोर्थ आउटपुट हैज बीन सिलेक्टेड. इसी तरह अगर पहला आउटपुट जो है वो सिलेक्ट कर लें, आउटपुट पे कोड क्या आएगा? 0 0. इसी तरह अगर आपके पास 8 to 3 encoder है, it would have 8 inputs and 3 outputs. So अगर पहला वाला इनपुट आप सिलेक्ट करते हैं, आउटपुट पे 0 0 0 आएगा. अगर आखिरी वाला इनपुट सिलेक्ट करते हैं, then you would have 1 1 1 at the output. So आउटपुट पे हमेशा एक 2 बिट या 3 बिट कोड आएगा जो रिप्रेजेंट कर रहा है कि आपने कौन सा इनपुट सिलेक्ट किया हुआ है. Let us have a look at the implementation of a 8 to 3 encoder. उसका पहले फंक्शन टेबल देखते हैं कि कैसे फंक्शन परफॉर्म करता है, उसके बाद उसकी implementation using simple gates वो देखते हैं. Let us consider the function table of an 8 to 3 encoder which has active high inputs and active high outputs. It has 8 inputs I0, I1, I2, I3, I4, I5, I6 and I7. It has 3 outputs O0, O1 and O2. Now, looking at the second row, I1 is set to 1, all other inputs are set to 0. I0 input is don't care, it could be 0 or it could be a 1. The output is 0, 0, 1. This means input 1 has been selected. Looking at the third row, I2 is set to 1, all other inputs are set to 0 and input 0 is either 0 or 1. The output shows the 3-bit code to be 0, 1, 0. Similarly, looking at the last row, I7 is set to 1, all remaining inputs are set to 0. The output indicates the code 1, 1, 1. Now, looking at the implementation of an 8 to 3 encoder, only 3 OR gates are used and each of the 3 OR gates have 4 inputs. Now, let's suppose I1 is activated, so I1 would have a logic 1. What should be the output code? Basically, it should be 0, 0, 1. Now, it can be seen in the diagram that I1 is connected to the input of the first OR gate, which has an output of O0. So, if I1 is 1, output O0 is going to be 1, output O1 is going to be 0, and output O2 is going to be 0. Similarly, looking at the input I7, when this is activated, you should get an output code of 1, 1, 1. So, by following the connection of I7, it is connected to the input of the first OR gate, it is also connected to the input of the second OR gate and the third OR gate. So, whenever I7 is selected, a 1 is applied at the input, all 3 OR gates would provide an output of 1, 1 and 1 respectively. Similarly, looking at the input I4, I4 should generate a number 1, 0, 0. O0 should be 0 and O1 should be 0, O2 should be 1. Following the connection of I4, it is connected to the input of the last gate, which has the output O2. O1 and O0 OR gates are not connected to I4. Now, looking at I0, when this is selected, the output should be 0. So, in the circuit, it is shown as not connected. We have just seen the implementation of a 8 to 3 encoder. उसका function diagram भी देखा, उसकी implementation देखी. Implementation जो है बड़ी simple सी है. 3 हमने OR gates use किए, तीनों के 4 inputs हैं. Now, there is a problem with this particular circuit. Can you spot the problem? What could go wrong with this particular encoder? Well, the problem is, अगर आप 2 inputs simultaneously select करें, what is the output going to be? Let's take an example. आप input 1 और input 6 simultaneously select करते हैं. So, input 1 की वजह से output पे code क्या आएगा? 0, 0, 1, representing the 1 input. And for the input 6, the output should be 1, 1, 0. ये दोनों मिलके आपके पास आउटपुट पे कोड क्या आ रहा है? 1, 1, 1, 7. सो सिंपल जो इनकोडर है उसमें अगर आप एक से ज़्यादा इनपुट सेलेक्ट करते हैं जो आउटपुट पे कोड आएगा, दैट वुड नॉट बी करेक्ट. सो इसका हल क्या होना चाहिए? बेसिकली वी नीड टू मॉडिफाई द सर्किट. और सर्किट मॉडिफाई करके क्या होगा? बेसिकली वी असाइन प्रायोरिटीज टू इनपुट्स. सो इनपुट 6 की प्रायोरिटी इनपुट 1 से ज़्यादा है. सो इफ़ यू सेलेक्ट इनपुट 1 and 6, the output should give the code for input 6. Similarly, if you select the input 4 and 5, the priority of input 5 is more than input 4. So, at the output, you should only see 1, 0, 1. Now, encoders which prioritize their inputs are known as priority encoders. Priority encoders का logic क्या होगा? कैसे उसको पता लगेगा कि ये input ज़्यादा priority का है as compared to another input? Basically, simple Boolean expressions लिख सकते हैं उसमें और उस basis पे हम एक circuit define कर सकते हैं उसमें. So, let us take a very simple example. I2 has a higher priority than I1. तो इसके expression क्या होगा? Basically, I2 and I1 का जो output पे I2 की वजह से जो output पे आ रहा है 0, 1, 0 आएगा and I1 की वजह से output पे जो आ रहा है 0, 0, 1 आएगा. So, we could write an expression based on the input I2 and I1, saying that when I2 is active and I1 is active, the output should give the code for I2. Let us have a look at the priority encoder. Let us have a look at the Boolean expressions which have been derived and on the basis of which we implement the priority encoder circuit. Let us develop Boolean expressions for the 3 outputs O2, O1 and O0 of a 8 to 3 priority encoder. Now these expressions can be written in terms of some variables. So O2 is equal to A7 plus A6 plus A5 plus A4. What do these variables represent? Basically, if you look at the priority encoder's output O2, O2 is going to be set to 1, or it is going to be activated when the 7th input is selected, or the 6th input is selected, or the 5th or the 4th input is selected. Similarly, the expression, the Boolean expression for output 1 can be written in terms of these variables A7 plus A6 plus A3 plus A2. So this means that the output O1 is going to be activated when any of the 4 inputs, that is 7, 6, 3 or 2 are selected. Similarly, the Boolean expression for O0 output can be written in terms of A7 plus A5 plus A3 plus A1. That is, the output 0 is going to be activated when any of the 4 inputs, that is the 7th input, the 5th input, the 3rd input or the 1st input are selected. The terms A7, A6, A5, A4 up to A0 can be written in terms of the inputs. So A7 is equal to I7, the input. A6 is equal to I7 bar I6. I7 and I6 are the 2 inputs, the 7th and the 6th inputs respectively. Similarly, A5 can be written in terms of the 7th, 6th and the 5th inputs. So it is I7 bar, I6 bar, I5. A4 can be written as I7 bar, I6 bar, I5 bar and I4. And lastly, A0 can be written in terms of the inputs as I7 bar, I6 bar, I5 bar, I4 bar, I3 bar, I2 bar, I1 bar and I0. Now, replacing the variables A7, A6, A5 and A4 for the expression O2, we have O2 equals to I7 plus I7 bar I6 plus I7 bar I6 bar I5 plus I7 bar I6 bar I5 bar I4. Now, what does this expression represent? If the input I7 is selected, it should be set to 1. Similarly, if both the inputs 6 and 7 is selected, according to the expression, output 2 would be activated. Again, if the input I7 and I4 is selected, according to the expression O2, output would be set to 1. Now, simplifying the expression I7 plus I7 bar I6 plus I7 bar I6 bar I5 plus I7 bar I6 bar I5 bar I4 gives I7 plus I6 plus I5 plus I4. Similarly, looking at the output expression for output 101, it can be written in terms of the input terms as I7 plus I7 bar I6 plus I7 bar I6 bar I5 bar I4 bar I3 plus I7 bar I6 bar I5 bar I4 bar I3 bar and I2. If you simplify this expression, you end up with I7 plus I6 plus I5 bar I4 bar I3 plus I5 bar I4 bar I2. And lastly, the expression for output 0. It can be written in terms of the inputs as I7 plus I7 bar I6 bar I5 plus I7 bar I6 bar I5 bar I4 bar I3 plus I7 bar I6 bar I5 bar I4 bar I3 bar I2 bar and I1. If you simplify this expression, you end up with the expression I7 plus I6 bar I5 plus I6 bar I4 bar I3 plus I6 bar I4 bar I2 bar I1. Now, looking at the Boolean expression for output 1, which is I7 plus I6 plus I5 bar I4 bar I3 plus I5 bar I4 bar I2, it is going to be set to 1 if the inputs 7, 6, 5, 4 and 3 are not selected. So the last term, which is I5 bar I4 bar I2, would set the output to 1 because of the presence of I2, the input 2. Based on these 3 Boolean expressions, a priority based circuit can be implemented. The function diagram of the 8 to 3 input priority circuit is shown. It has 8 inputs and another input which basically enables the chip. So E1 bar is active low. It is set to 0 to activate the 8 to 3 priority encoder. The remaining 8 inputs I0 to I7 are all active low. So in order to select an input, you have to apply a 0 at the appropriate input. There are 5 outputs, A0 bar, A1 bar, A2 bar, representing the 3 active low outputs. There are 2 additional outputs, EO bar and GS bar. The EO active low output represents the enable output and GS active low output represents the group select output. The group select output and EO output, the enable output, are used to connect multiple 8 to 3 priority encoders to form larger encoders. The 2 active low outputs are used to connect multiple 8 to 3 priority encoders to form larger encoders. Now, looking at the function diagram again, let's suppose the input 4 is selected. So it is going to be selected by applying a 0 there. All the remaining inputs I5, I6, I7 have to be a 1. The inputs which are at a lower priority, that is 0, 1, 2 and 3 can be 0 or 1. The output of the priority encoder would be 0, 1, 1. Similarly, if input 1 is selected, it is set to 0. All the higher priority inputs have to be 1, indicating that they are inactive. The input 0, that is the first input, can be either a 0 or a 1. The output would indicate 1, 1, 0. The 8 to 3 priority encoder, which we have just looked at, the function diagram and its implementation, is basically the 74148 8 to 3 priority encoder. Now, you can implement a larger priority encoder, that is 16 inputs and 4 outputs, by connecting two of these 8 to 3 priority encoders. So, how would you connect them? As we mentioned, you have two outputs, the enable output and the group select output. Basically, these outputs are used, the enable output particularly is used to connect the two 8 to 3 priority encoders. So, let us have a look at the implementation. In order to implement a 16 input priority encoder, you have to use two 8 input priority encoders. The three outputs are connected together through 3 NAND gates. The active low enable output pin of the first 8 input priority encoder is connected to the active low input pin enable input pin of the second 8 input priority encoder. Now, let us suppose you select input 4 in the first priority encoder. What happens? The output shows the code 4. If you look at the function diagram, the enable output of the first encoder is set to 1, which means the second encoder is not selected. Similarly, if you select the input pin 8, which is the first pin of the second encoder, the output would be set to 8. Let us suppose that we select the input 0 of the second encoder, which means it is the 8th input of the 16 input priority encoder. What is the output? Basically, the output would be 0, 0, 0, because input 0 has been selected of the second encoder. E3 output would be set to 1. Looking at the function table, the first encoder has not been selected. None of the 8 pins have been selected. Therefore, the E0 output would be set to 1. Therefore, the 4-bit code is 1, 0, 0, 0, representing the 8th input which has been selected. Let us look at another encoder, the BCD-To-Decimal encoder. The BCD-To-Decimal encoder has 4 inputs, rather 10 inputs representing the 10 decimal digits, 0 to 9, and the output is 4, of course representing the BCD number. So, where are we going to use this? Basically, you have a keypad जो आपके टेलीफोन पे लगा हुआ है या कंप्यूटर के जो न्यूमेरिक कीपैड है उसमें भी 10 डिजिट होते हैं उसमें. Now, when you press any number, you need to code that into binary or BCD so that the rest of the circuitry can use that number. So, क्या होगा? Basically, you would connect each of the 10 keys of your keypad to the 10 inputs of the decimal to BCD encoder. So, whenever you press any key, you would get an output BCD code which represents the key number. Of course, this decimal to BCD encoder is a priority based decoder. So, if you press 2 keys, you would simply get a single output representing the number of the highest priority digit. The 74147 is a decimal to BCD priority encoder. It has 10 active low inputs representing the decimal digits 0 to 9. It also has a 4-bit BCD output. All outputs are active low. Now, at the 10 inputs of the the decimal to BCD priority encoder, 10 different keys are connected. One end of each key is grounded and the other end is connected to 5 volts through a resistor. So, whenever a key is pressed, the output, the appropriate input of the priority encoder would be set to 0 because the key connects the input of the priority encoder to the ground. So, let us suppose key 0 is pressed. So, the input 0 would be set to 0. The output would give the code 0, 0, 0, 0. Let us suppose the key number 7 is pressed. Input at pin 7 of the priority encoder would be set to 0. The output would be 0, 1, 1, 1 representing the number 7. If none of the keys are pressed, the outputs at the input of the priority encoder would all be high. Therefore, the output BCD code would be all ones. We have looked at the implementation of priority encoders and we have also looked at the application of a priority encoder. Basically, जो keypad है आपका वो आप connect करते हैं priority encoder के साथ. Whenever you press a key, you get a 4-bit BCD representing that particular key. Now, that 4-bit BCD can be used by your digital system for further processing. Another important, rather a very important functional device is the multiplexer. Multiplexer क्या है? Basically, it's like a data switch. It has multiple inputs and a single output. Now, by selecting any one input, the data at that input is routed to the output. Let us talk about a 4-to-1 multiplexer. 4-to-1 multiplexer of course has 4 inputs and a single output. In addition to the 4 inputs and a single output, you have data select inputs. So you would have 2 data select inputs. So by writing 0, 0 at the 2 data select inputs, you would be selecting the first input, and the data available at that first input, it could be 0 or 1, it would be directly routed to the output. So अगर पहले इनपुट पे आपने सिलेक्ट किया है और उधर जो डाटा है वो 0 है, आउटपुट पे आपको 0 नजर आएगा. अगेन अगर आपने पहला इनपुट सिलेक्ट किया है उस पे डाटा 1 है, वही 1 जो है आपको आउटपुट पे नजर आएगा. सिमिलरली यू कैन सेलेक्ट द लास्ट आउटपुट बाय अप्लाइंग 1 1 एट द डाटा सेलेक्ट इनपुट्स. जब 1 1 आप करेंगे, चौथा इनपुट सेलेक्ट हो जाएगा, उस पे जो भी डाटा वैल्यू है 0 या 1 वो आपको आउटपुट पे 0 या 1 की शक्ल में नजर आएगी. इसमें let us have a look at the function table which represents the operation of a 4-to-1 multiplexer and the implementation of a 4-to-1 multiplexer. But before that, multiplexers use कहाँ होंगे? बेसिकली जो आपका माइक्रो प्रोसेसर है, ALU की अरिथमेटिक लॉजिक यूनिट की हमने बात की थी. अरिथमेटिक लॉजिक यूनिट के 2 इनपुट्स होते हैं. उन 2 इनपुट्स पे आप क्या करते हैं, 2 डिफरेंट वैल्यूज या क्वांटिटीज आप अप्लाई करते हैं. देन यू सेलेक्ट द ALU फंक्शन. ALU जो है उस पर ऑपरेशन परफॉर्म करता है, ऐड करेगा, सब्ट्रैक्ट करेगा, लॉजिकल ऑपरेशन करेगा. जो 2 क्वांटिटीज हैं वो कहाँ से आएंगी? बेसिकली इनसाइड द माइक्रो प्रोसेसर आपके पास डिफरेंट लोकेशंस हैं विच आर नोन एज रजिस्टर्स. रजिस्टर्स आर लाइक स्मॉल मेमोरीज. उन रजिस्टर्स में आपके डिफरेंट क्वांटिटीज या वेरिएबल्स पड़े हुए हैं. सो लेट्स से आपने जमा करना है वेरिएबल ए, द कंटेंट्स ऑफ वेरिएबल ए विद द कंटेंट्स ऑफ वेरिएबल बी. सो आप क्या करेंगे, जो रजिस्टर ए है विच रिप्रेजेंट्स वेरिएबल ए एंड रजिस्टर बी विच रिप्रेजेंट्स वेरिएबल बी, उन दोनों को आप सिलेक्ट कर लेंगे. उन दोनों का जो इन्फॉर्मेशन है, जो डाटा है, वो आप कनेक्ट कर देंगे दोनों ALU के इनपुट्स पे. सिमिलरली इफ यू नीड टू मल्टीप्लाई द वेरिएबल सी विद वेरिएबल बी, फिर आप क्या करेंगे, जो रजिस्टर सी है उसके कंटेंट्स और रजिस्टर बी है उसके कंटेंट्स वो आपने कनेक्ट कर देने दोनों ALU के इनपुट्स पे. Now as you can see there are multiple inputs. आपके पास let's say 10 रजिस्टर्स हैं ABC से लेके आगे तक. So 10 रजिस्टर्स हैं, उनमें से किसी एक में से आप डाटा सिलेक्ट कर सकते हैं. So 10 different inputs, 1 output. आउटपुट क्या है, वो ALU का जो इनपुट है. So आपके पास 2 मल्टीप्लेक्सर यूनिट्स होने चाहिए, दोनों के 10-10 इनपुट होने चाहिए और 1 आउटपुट होना चाहिए. सो बाय सेलेक्टिंग द अप्रोप्रिएट इनपुट आप अप्रोप्रिएट रजिस्टर से डाटा आप रूट कर सकते हैं ALU के आउटपुट्स पे. सो ये मेन एप्लीकेशन है. देयर आर अदर मोर इंटरेस्टिंग एप्लीकेशंस जो हम बाद में देखेंगे. सो लेट अस फर्स्ट लुक एट द फंक्शन टेबल ऑफ द मल्टीप्लेक्सर एंड इट्स इम्प्लीमेंटेशन. लेट अस हैव अ लुक एट द 4-to-1 multiplexer. It has 4 inputs and 1 output. You can select any one of the inputs by applying the select inputs. So there are 2 select inputs, S0 and S1. So when they are set to 0, 0, the output is connected to the first input or I0. By applying the select inputs to 0, 1 or setting the select inputs to 0, 1, the input I1 is routed to the output. Similarly, by selecting input values 1, 0, the input to I2 is routed or attached to the output. And lastly, when the select inputs are set to 1, 1, I3 input is connected to the output. So any values at the appropriate inputs are available at the output. Now looking at the implementation of the multiplexer circuit, you have 4 AND gates. Their output is connected to the OR gate. Now looking at the input 0, the first AND gate is selected when the select inputs are both zeros because they are connected through inverters. Now the first gate is enabled when S0 and S1 are both zeros. Whatever the input at I0, it could be 0 or 1, it is passed through the AND gate and it is seen at the Z output. Other 3 gates are not selected, so the output of the AND gates, the other 3 AND gates is 0. So the output of the OR gate depends on the output of the first AND gate. Similarly, if S0 and S1 are both 1s, the last AND gate is selected, all the remaining 3 AND gates are deselected, so their output is 0. Now if I3 is 0, the output of the 4th gate is 0 and the output of Z or the output of the OR gate is also 0. If I3 is equal to 1, the output of the 4th AND gate is 1, the output at the OR gate Z is also a 1. So basically by selecting the appropriate input, the appropriate data values at the respective inputs are passed to the output. We have looked at the implementation of a 4 input multiplexer. Commercially, there are different type of multiplexers available in different configurations. So you have 8-to-1 multiplexer which has 8 inputs and any one input or any single input can be connected to the output. जो function select pins होंगी वो 3 होंगी क्योंकि आपने 8 में से एक input को select करना है. Similarly, you have 16 input multiplexer which has 16 inputs, 1 output. जो function select or rather input select pins हैं वो 4 होंगी. The multiplexer which we are just going to discuss now इज ए क्वाड 4 इनपुट मल्टीप्लेक्सर. बेसिकली चिप है 153, उसमें दो 4 इनपुट मल्टीप्लेक्सर्स लगे हुए हैं उसमें. सो यू कैन यूज देम सेपरेटली और यू कैन कनेक्ट देम टुगेदर टू फॉर्म डिफरेंट कॉन्फ़िगरेशंस. ये जो 4-to-1 मल्टीप्लेक्सर है, जो क्वाड मल्टीप्लेक्सर्स हैं, इनका जो इम्प्लीमेंटेशन है, जो गेट्स जो हमने यूज़ किए हैं, इट इज़ वेरी सिमिलर टू द सर्किट यू जस्ट सॉ, except for that you have 2 chip enable pins, so you can individually select both the multiplexers together or separately. Let us have a look at the implementation of the quad 4 input multiplexers. Let us have a look at the quad 4 input multiplexer. That is, each multiplexer has 4 inputs and a single output. The first multiplexer has the inputs 1C0, 1C1, 1C2, 1C3. The output is 1Y. The second 4 input multiplexer has the inputs 2C0, 2C1, 2C2 and 2C3. The output is 2Y. The implementation is similar to the 4 input multiplexer which we discussed previously. Each multiplexer uses 4 AND gates and an OR gate. The AND gates have 4 inputs. Basically, one input is from the input to the multiplexer, the other input is from the chip select. So there are 2 chip selects, 1G for the first multiplexer and 2G for the second multiplexer. Both these chip selects are active low, therefore you see 2 inverters at the respective chip selects. The other 2 inputs to each gate and gate is from the input select A, B. The input select A, B are again active low. Basically 2 NOT gates are connected together. Why do we have extra NOT gates? Basically to reduce the fan out. If we do not have the extra NOT gate connected at the A input, how many gates does the external circuit see? Basically an inverter and 4 other AND gates. So the fan out would be reduced by 5 because the unit load is 5 for this particular circuit for the input A. Similarly for input B, if the first or the extra inverter is not connected externally, the fan out would be reduced to 5 because input B is connected to 5 gates, the NOT gate and 5 AND gates. Now both these multiplexers can be operated independently. Let's suppose you need to use the first 4 input multiplexer, so you would be connecting or using the first 4 inputs IC0, IC1, IC2 and IC3. You would be using the chip select 1G. The input select pins A and B are connected to both the to both the multiplexers. So if the second multiplexer is not used, the inputs A and B would not make any difference. We have looked at the implementation of a dual 4 input multiplexer. As I said before, there are different configurations जो हम next lecture में discuss करेंगे. अपना ख्याल रखिएगा. अगले लेक्चर में हम डिस्कशन दोबारा मल्टीप्लेक्सर से स्टार्ट करेंगे. खुदा हाफिज़. अस्सलाम वालेकुम.